We are going to look today at polynomials, and this is lesson 14.1 in your books. And of course, today's date is the 3rd, February 3rd. Okay, so let's jump right into this. Please take really good notes, and here we go. Okay, so let's start off by looking at a definition of a polynomial. Okay, here it is. Now, I'm sure that certain people, whoever's running the video, will have to pause the video at different times, and that's fine. But I would like you to copy this definition down. Okay. Now, guys, I'm going to keep moving, so people will have to pause the video numerous times throughout the video. Okay, so a polynomial is an algebraic expression that consists of at least one term. Okay, these terms have certain characteristics, and here are the characteristics. The coefficients have to be real numbers. Now, we have yet to really talk about imaginary numbers, so we're not going to worry about that right now, okay? But just to give you a formal definition, your coefficients have to be real numbers, okay? And the other characteristic is the exponents of the variables have to be non-negative integers. That means they have to be whole numbers, 0 or greater. So 0, 1, 2, 3, etc. Okay, so let's break this down. Please take really good notes. Are you ready? Okay, a polynomial is an algebraic expression that has at least one term. Here, please copy that in your notes. Okay, I think we can all agree that this is an algebraic expression and it has at least one term. In fact, it actually has more than one term. There's one term, there's another term, and there's another term. So this polynomial is an algebraic expression, and it has at least one term. In this case, it has 3, okay? Now, moving on, there are some other certain characteristics. Here's one of them. The coefficients have to be real numbers, okay? So that's a coefficient, that's a coefficient, and that's a coefficient. In case you have forgotten what a coefficient is, it is the number in front of each term. Okay, so I've got 3 terms. 1, 2, 3, and this is the number in the front. All of those coefficients are real numbers, okay? Moving on. Now, the exponents of the variables have to be non-negative integers. Well, let's see. There's an exponent. There's an exponent. By the way, hold on. It's exponents. Are you listening? Of the variables. We don't care about the coefficients. This 2 right here could have a power of -10, and I am totally good with that, okay? We are looking at variable exponents, okay? So I have 2, a 3, a 4, and a 10. Are all of those integers? Yes. Whole numbers? Yes. And are they non-negative? Yes. So, yes, this is a polynomial. Okay? Now, let's talk about different types, okay? Based on the number of terms that a polynomial has, we can give different names to polynomials. For example, If a polynomial has one term, we call that a monomial. If a polynomial has two terms, we call it a binomial. And if a polynomial has three terms, we call that a trinomial. Okay? Now, let's practice this, okay? Here we go. And not sure what's going on here, so hold on one second. Okay, guys, I'm back. So, anyways, not sure where those extra slides came from, but anyways, if there's one term monomial, two terms binomial, three terms trinomial, in fact, let's go back and look at the example you already have in your notes, which is this one right here. What is this? Well, let's see. It's a polynomial and it has three terms. One, two, three. So, what type of polynomial is it? It is called a trinomial. Okay, now let's practice. Okay, there. That is a polynomial. How many terms does it have? And please don't say three. All of these are being multiplied, so it's one term. We call this a monomial. This has two terms, and so we call it a binomial. Now, guys, a lot of you like to have really thorough notes, okay? And I know I'm going fast. You'll just have to ask the person in charge to pause the video, okay? All right. This is an example of a hold on. Mr. Earhart, this is not a polynomial. We have a negative exponent here. Yes, you do, but remember, we don't care about numerical bases. We're looking at the variables, and this variable is positive. This variable's exponent is positive, and this variable's exponent is 1, and it's also good. Okay, we don't care if this is negative, that's fine, because its base is not a variable, its base is a number. Okay, all right, this is a trinomial. Okay, trinomial. Now let's talk about the degree of each of these polynomials. Please pay attention and watch. Okay, the degree, I would write this down, the degree of a polynomial is the largest sum. That means you're going to add of all of the variable exponents of each term. That means you look at each term, add up all of the exponents, and then you find the term that has the largest sum. Okay, let me show you what I mean. Here we go. So, all right, here, let's take a look at this. Sorry about that. Let's take a look at this monomial. Okay, your B has a power of 1. Your C has a power of 1. We do not care about the 3. Okay, we're looking at variable exponents. Okay, and 3 is not a variable. It says sum, so we're going to add these together and we get 2. So we call this a second degree. Alright, let's try the next one, okay? Alright, let's look at this binomial. Here, in this term, I have one exponent. I don't care about this exponent. I'm looking at my variable. I have one exponent. So the sum of all of my exponents here is 3. Now, I come over here. Let's look at this term. I have an exponent of 2 and an exponent of 2. Add those together and we get 4. Obviously, which number is bigger? 4 is the bigger number, so we call this a fourth degree. Do you see what I'm doing? I do that for each term. Okay, so next problem. Let's look at this trinomial here. What is the degree? Well, let's see. My first term here has no exponents because remember, I am looking for variables and there's no variables here, so I have no exponents, so 0. Now, let's look at this term. I have one variable and the exponent is a 3, so my sum of all of my exponents is 3. Now, next term, I have an exponent here and an exponent here. If you add those together, you get 3. Well, which term, this one, or this one, has the largest sum? Well, these two are the same, so we just call it a third degree. Okay? All right, hope that makes sense. Now, let's start simplifying these things. Here we go. Please copy that in your notes and let's simplify this. Remember, you can only combine like terms. Okay, so this is what I call an r cubed terms. And this is an r cubed term. We do not care about the coefficients when we are looking for like terms. Coefficients do not matter, just the variables and their exponents. Okay, so I am looking for like terms, and we've learned this before, but anyways, I have an r cubed and an r cubed, so let's combine those. You can use calculators now if you need to. A positive 3 and a negative 4 is a negative 1 r cubed. The r cubed does not change, okay? And by the way, if you don't want to put this negative 1 here, you don't have to. That's up to you. Now, I have an r squared and an r squared. They're like terms, negative 2, positive 5, positive 3r squared. You know you're finished because you have no more like terms. This is an r cubed term. This is an r squared term. So you are finished. All right, let's try this one, okay? I have a p squared, and a q to the fifth. Men, ladies, order does not matter, okay? My p has a 2, my p has a 2, my q has a 5, my q has a 5. It does not matter the order, it's multiplication anyways. All of these are being multiplied, all of these are being multiplied, so order does not matter. Now remember, I have a 1 right here, so positive 1, negative 4, negative 3. By the way, you can put p squared q to the fifth, or you can put q to the fifth p squared. I don't care, does not matter, okay? Now, these two terms are the same. P to the fifth, p to the fifth, q to the fourth, q to the fourth, negative 4, positive 3, combine those, and we get a negative 1, okay? And if you do not want to put that negative 1 right here, you do not have to. Totally up to you. Okay, all right, let's try this one, and we're finished, okay? So, again, I'm going fast. Whoever's running the video should be pausing the video, okay? All right, I have r cubed, positive 5, negative 1, that's a positive 4, r cubed. Now, I'm going to check those off so I know I'm done with those. Now, r squared, s to the 1, s to the 1. These are like terms. Remember, there's a 1 right here, so negative 1, negative 3. If you got to use a calculator, feel free to, it would be negative 4r squared s. And now check those off. Okay, now there's only two terms left that we haven't used. Okay, and notice both of those terms are like. Okay, they are like because they have no what? No variables. Okay, and we have a name for those. We call them constant terms. Okay, constant terms. Now, 2 to the 5th is the same thing as 32. 2 times 2 times 2 times 2 times 2. And now combine those and you get 38. Okay, now how do we know we're finished? Well, I have an r cubed term. I don't see any r cubed terms. I have an r squared s term. I don't see any of those terms up here to match that. I have a constant term. I see no constant terms. So we know that we're finished because there's no more like terms. Now, let's real quick practice what we learned earlier. Okay, is this a monomial, binomial, or trinomial? Let's see. It's a trinomial because I have 1, 2, 3 terms. Okay, now what degree is it? Well, let's see. If I add up all of my exponents here, I get 3 because, yes, the 4 has a power of 1, but we don't care about the 4. It's not a variable. Here we have a variable with a power of 2 and a variable with a power of 1. Add those and you get 3. Here we have no variable, so 0. So which term had the most exponents? Well, these two did. They both have 3, so we call that a third degree. Okay, men, ladies, that's good enough. That's all we're going to do for today is just take notes, email me if you have any questions, and we will work on homework on this tomorrow.